Good evening, everyone. Welcome to seventh live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta, and I am a PMRF fellow and a PhD scholar from Department of Design, IIT Guwahati. So the agenda for this class is to help you with week 7 assignments. So have you gone through the lecture videos from week 7?
Yes, some.
Okay. So the deadline for assignment is tomorrow, 14th September. So if you have not finished the assignments, please finish them on time. And this particular session will be conceptual because the nature of the assignments are objectives. So I will try to cover some of the key concepts that will help you in solving those assignments. Okay.
Yes, sure.
Okay. So what we learned in the last class. So have you attended the last class?
Yes.
Okay. So I'll briefly talk about some of the key topics from last class. So one is constraint versus function. So after we come up with our specifications, like the product specifications, we know the nature of the specifications are a matrix plus a value, right? For example, 50 kg. So this kg is a matrix, that is the weight, and 50 is a value. So some of these specifications you consider them as constraints in your design, and some of them are functions. So okay, so which of the functions you use as a constraint? For example, you want to design a bike, and weight of the bike has to be less than 180 kg. Okay. And another specification can be like luggage carrying capacity is to be like 155 kg. Okay. Okay, so tell me, which among these two, which is a constraint and which is a function? Both are specification, product specification, but during design you consider one of them as function and one of them as constraint.
Weight of the bike less than 180 kg is a constraint under which we have to design the bike, and luggage carrying capacity equals 155 kg. This is a function that we have to maintain. At least it should be able to sustain this much luggage carrying capacity.
Okay, and why you define this one as a constraint and this one as a function?
As above one is restricting the weight of the bike with a metric value. That's why I consider this weight of a bike is less than 180 kg is a constraint for the designing of the bike.
Okay, so basically we define constraint and function from one perspective, that is, can we solve or can we work on that particular specification? Okay, so when we design a bike, we can actually design for luggage carrying capacity. So we can actually design the chassis, we can decide upon the thickness of the pipes, we can also play with the structural arrangement, and we can actually design for carrying 155 kg. Okay, but weight of the bike less than 180 kg is not something we can decide prior to deciding all the various components, because a bike may have a fuel tank, then we have chassis, we have engine, then we have the chassis, then the seats, wheels. Okay, so at the end at the end only we can think about like what is going to be the weight of the bike. So we don't actually have a direct control on the weight, but it's a uh, it's a number that we get after deciding various components and various parts of the particular design. So we kept that as a constraint because we cannot go straightly deciding on the that particular specification. We cannot design upon that, but we can design upon luggage carrying capacity, so we consider it as a function. Okay, so next what we learned in last class was functional decomposition. So what is functional decomposition? Do you remember?
Yes, in functional decomposition, we give actually use fast method to identify all the functions of individual parts uh, of a product.
Okay, so functional decomposition is basically breaking product functions. You have a higher product function, right? So product functions into individual sub functions. So basically we are decomposing sub functions. Sub functions. Again, sub functions can be another sub functions. So this particular process of breaking down the higher level functions into smaller functions, sub functions, is known as functional decompositions. For example, I discussed last time, like design like functional decomposition of a mixie grinder. So the overall objective is to grind masala. So grind masala, but when you move to sub functions, it will come like rotating blades, then storing masala, like that, then easy to clean. So these rotating blades can be electrical motor. So like that we break down the higher level functions into smaller level functions. So we discussed two methods. One was SOP method and one is fast method. So what was SOP method? Do you remember?
Yes, in a SOP method, we actually uh, one by one remove all the components and try to identify its function in a product.
Yes, correct. So we start removing the very smallest, possible functional block, and then after removing, we then start operating the procedure, and we try to analyze the relationship and what function miss when we operate without that particular functional block. And after we do this particular task iteratively, we then come to know what are dependencies, who is a child and who is a parent. So these parent child relationships can be easily analyzed by using this method. So slowly after many iterations, we actually come to know about the various functionalities and sub functions. However, there's a limitation of this particular method. One is that this is mostly useful for reverse engineering because you need something already existing. Okay, so for new product development, this will not be helpful. Again, there are issues like sometimes there are some functional blocks. When you remove, you may not see visible change in the functionalities. For example, if this is something like a glowing LED, okay, and you have three components, and probably just removing one particular component may not result in change in the parent level function. So we may not know what is the use of this particular function. So we'll feel that this is something redundant, but actually this way of analyzing functional functions, more like a black box, is not always helpful when we do not when this kind of relationship or characteristics does not reflect when we remove something. The other method was fast method, and the benefit of this is that this can be used for new product development also. So what we do here, we make two lines. We start actually from the output to the input. So here is the output, which means the highest high level function, and then as an input we consider something assumed function like input like electricity, right? Very basic one. And then we start asking how, like we if for example, for a mixie grinder, if high level objective is to grind masala, then we ask first how. Then you say, okay, you grind it. So how to grind? You say using blade. Then how? You say rotating blade. Then how to rotate? Using motor. How to rotate motor? Using electricity. So like that we connect from output to input, asking the question how, and we verify the same thing, asking the question why, from left to right, from input to output. Clear?
Yes, sir.
Okay, so what was the name of this particular functional part? Do you remember?
Critical path concept.
Yes, this is critical
Critical
function
path.
function part, and you have then under every critical functional blocks we have sub functions. Okay, so these are sub functions, and in this fast method we can also detect various unwanted functions, for example, which are not desired, but because of the system design you may realize that certain noises starts coming. So those are not desired functions, but those are resultant of some other function. So those are called as unwanted functions. Okay, and there are again one-time functions. For example, when you want to transport particular product, so packaging and transportation, safety, protection, all these things come as one-time function. Okay. So after we develop that, we use something called function tree to represent the particular function and sub functions. Okay, so this particular functional tree is helpful when you actually try to convert and go for product form design or product architecture design, because this is the basis. This is the on the basis of this particular function tree you can next move forward for working on functional architecture, that is the product form. So this was what we learned in the last class. So one thing I like discussed in the last class, that these two methods are actually used, are these are simple methods, okay, simple techniques, and these are used for only simple products, okay, because as the complexity of products increases, there are dependencies arises between different functional blocks. So it is not very easy to represent a complex product using just a simple functional tree. Okay, so in today's class, first we'll discuss something known as common basis. Okay, okay, do you know what is common basis? Okay, so let me ask you a question. So when you break down a high level function, for example, high level function of this particular trimmer is to trim, right? Trim or shave. Okay, shave here. So what is the next task in functional decomposition? We break down it into sub functions. Then again we break down into sub functions, and at the end we arrive at the individual elements, mechanisms, circuits which are actually useful for designing this particular product. Okay, but when we stop in a functional decomposition process, we can keep on going, right, breaking down things, like again breaking down, and probably at the end we'll enter at the pure science level, probably we'll enter at physics level, chemistry level. Everything at the end has some relationships. So if I talk about a motor, if you do not stop at the motor level, you can go keep on going to magnetic energy, you can go to flux level, you can go to basics of material property. So breaking down a higher level function and into sub function is a very it's not easy to stop at one particular level. And for your product design purpose, you need to stop at one level. Okay.
Yes, yes,
Okay. So for that purpose, we use something known as common basis. Okay. Common basis means there are certain verbs that follow nouns. For example, we I discussed in the last class, like how to write functions, like like rotate.
yes. Whether noun and a verb.
Yes, so rotate blade, so it's a verb or noun. Okay, plus noun. So when you reach this verb, so there are a set of classes defined for representing some of the basic or basis verbs that defines the functions. So at this stage, when you can break down a function to a sub functions, which is something like this, import. What happened?
Hello.
Sorry, there was a disconnection. Am I audible?
Yes, yes,
Okay, so is my screen visible?
yes.
Okay, so I was discussing something. What happened? Okay. Something happened, it might be. Okay. Okay, sorry for the interruption. So whenever we can reach to this particular level, okay, using this sort of verbs along with particular noun, we can stop the process of functional decomposition. Okay, clear?
Yes,
Okay, so for example, what we did previously, when we break down this particular, for example, the mixie grinder, when we say uh, grind masala, and then we break down into rotate blade. Okay, and then we move to uh, convert rotational sorry, E electrical energy to rotational. Okay, see, we use something called convert. So we have something already existing convert. That means we actually reach to a level. After that, we have the connection with the input electrical energy. Okay, so till this level we generally do the functional decomposition. So these are the, the lowest level sub function verbs that we can use for functional decompositions. So what are the advantages of this particular, let me remove it is few of these. What is the advantage of this particular, common basis? First thing is that it adds a common vocabulary for various functions and flows. You know, for example, if you are designing a trimmer, and if you are and designing something like a mixer, you may actually at the start initialize with different verbs. See, first verb was grind. Okay, here it will be trim. Okay, but at the end, everything comes down to something like rotate blades or convert. Okay, so this particular basis function constitutes something very common to all sort of products. So that's the reason why we have something common across different products. Understood?
Yes, sir.
Okay. Second thing is like, when we use this sort of vocabulary, it actually makes sense in terms of functional breakdown. Okay. So this is a robust vocabulary that empower experience of designers. That means sometimes what happen, whenever designer try to define something, he may use his own vocabulary which is not common to someone else. Sometimes his intention may not be understood by someone else. So this using the basic functions make sure that if someone else also review your functional decomposition diagram, he may also understand what sort of function you as a designer are actually expecting. Okay, so that's the reason why it's a robust vocabulary that actually define the true functional ability. The third is it's a common representation for various product domains. You can use it for electrical device, you can use for mechanical. So you start with something like electrical energy sensor, but at the end you end up with something using convert, transmit, something like that. So because of this commonality, it's very useful. And fourth is the obvious one, which is like, it provide a level at which a designer know that when to stop in a functional decomposition process. So whenever we reach this particular uses or use case scenario of these particular verbs, we know that we reach a lowest level functional decomposition process. Okay,
Uh,
any question?
yes. Is it this functional common basis have only these words, or it have more than these words?
It has actually more than these words.
Okay.
Sorry again.
So it's just like verb terms only, but they are more in number. But is it any defined number, or if it is not a defined number, then how can we can reach to a common ground?
No, these are some of the defined, these are examples. Already, this particular technique of functional decomposition is popular. So you can get papers or case studies where people have contributed with lot of such, verbs for functions. So these are some of the common verbs that you can use for defining your functions. And again, this is not something like no very much like a mandatory. You can choose your own verbs. The only difference is that when you use, you know, am I audible?
Yes, sir. Yes, sir.
Okay. I don't know why there's so much of. Okay. So when you use these sort of functions, okay, these kind of verbs, at least it is easy for someone else to understand what you mean. Okay. So that is
Yes.
one benefit. Otherwise, you can, there's no need to use these bases when you yourself is designing a particular product. Rarely what happens in a company or in an organization, the person who is actually designing, he actually does not work in a development phase. So as a designer, when you come up with certain functions and you come up with product architecture, so within the architecture when you define certain terminologies, and then this particular architecture when you move forward to someone like a engineering guy who actually starts procuring components or think about designing something. So these terminologies has to be something common across various disciplines within your organization also. So using these particular basic functions, it is easy. It is easy to make people understand what actually you mean by particular function. You can say use something like grind masala, okay, and you can use something. For example, see rotate blades. Rotate blades.
In the case of rotate, we can use also the spin or
Spin
any
blade.
other.
Yes, spin blade you can use. So then there are like wheel blade, okay. People may get confused with individual terminologies when so many different people use different terminologies within your own functional decomposition. Probably in different time you use different vocabulary. That may also happen, like you sometimes use rotate, sometimes you use spin,